Hi everyone, my name is Charlotte and today we're going to be doing a lesson on surds, which will include how to simplify them and how to rationalise the denominator. And I'll put timestamps for all topics I cover in the description, so if you're looking for something specific you can find it there. If you feel like you have a topic you want me to go through, then let me know in the comments, or additionally I do offer private tutoring, so if you're interested in that I'll put the link in the description as well. And you can message me and we can set up a lesson. But without any further ado, let's get to some surds. So we'll start with what is a surd. So a surd is just any square root of an integer. So for example, the square root of 3 is a surd. So this square root sign, if you don't already know, means what number squared gives you this integer here. So for example, we could have the surd, which is the square root of 64, and so this would be what number squared gives you 64, and this is equal to 8, since 8 squared is equal to 64. And technically this would be 8 or it would be minus 8, but just for this topic we'll just kind of focus on the positive square roots of things. So that's what a surd is, and so some surds can be simplified and some can't. So for example, the square root of 64 can be simplified, and we've simplified it to 8. However, the square root of 3 can't be simplified. This is it in its simplest form. So let's go over how to simplify surds. So let's take the example of the square root of 8. Now how would we simplify this? So we start off, we can write this as the square root of, well, let's think about the number 8. What is 8? Well, we know that 8 is equal to 2 times 4. So the square root of 8 is going to be equal to the square root of 2 times 4, right? So because we've got this times here, we can actually split this up into being the square root of 2 times the square root of 4. Now we can only do that because this symbol is a times. We could also do it if it was divided, but if it was plus or minus, then you can't simplify this. So the square root of 2 plus the square root of 4 is not equal to the square root of 2 plus 4. It has to be a times or divide for this work. So because this is a times, we can actually split these up. And so now we can look at these numbers individually and think, okay, can we simplify either of these? So the square root of 2, well, can you think of a number that when you square it, it gets 2? Not really, no. But if we look at 4, well, what number squared is equal to 4? Well, we know that 2 squared, which is 2 times 2, this is equal to 4. So the square root of 4 is 2. And so we have this as, well, because it's multiplication, we can swap these numbers around. So I'm going to do that. So this is equal to the square root of 4 times the square root of 2. Right, we're just swapping the numbers around, but that doesn't affect it because it's multiplication. And we know that the square root of 4, because of this, we know that that is equal to 2. So we can actually substitute this for 2. So we get 2 times the square root of 2. And just like you would in algebra, rather than writing like 2x, or you would write 2x rather than 2 times x, like they're the same thing. Same with this. You can just write this as 2 root 2. And that is equal to the square root of 8. It's 2 times the square root of 2. So that's how you would go about simplifying surds. So let's do another example. Let's simplify 3 times the square root of 32. Well, we can kind of ignore this 3 for now, so let's just leave it as 3 times. Square root of 32. Well, let's think of what two numbers times together give us 32, just as we did up here. Okay, well let's say 8 times 4, because 8 times 4 is 32, so these two things are still equal. So we have 3 times, and just as we did before, we can actually split these up. So we have 3 times the square root of 8 times the square root of 4. And well, this square root of 4, we know, as we did up here, that this is equal to 2. So we have 3 times the square root of 8 times 2. which is equal to, if we do this 3 times 2 here, this is equal to 6 times the square root of 8. And as we've worked out up here, we know that the square root of 8 is 2 times root 2. So this is equal to 6 times 2 times the square root of 2. And this 6 times 2 is 12. So we have this is equal to 12 times the square root of 2. Okay, so that's how you simplify this. So let's say now we wanted to simplify the square root of 8 plus 3 times the square root of 32. Okay, so how would we do that? Well, first, what we need to do is simplify each of these individual terms, and then maybe you can see something you can do with that. Okay, so this is a nice example because we've already simplified these two up here. So we've gotten that the square root of 8, we've simplified that, done all this, and we've got that that is equal to 2 root 2. So we can write this out as, well, the square root of 8, we can substitute that in for the square 2 times the square root of 2. And we've gotten that 3 times the square root of 32 is equal to 12 root 2. Okay, and now we can see, okay, we've got 2 root 2 plus 12 root 2. So just again, as in algebra, if you had 2x plus 12x, this is equal to 14x. If you haven't done this, don't worry, I will do a video on algebra, but if you have done this, then you know this, and if you haven't, then don't worry, we'll do it at some point. But if you haven't, just take my word for it. You have 2x plus 12x, and that's equal to 14x. And it's the exact same with surds. As long as these two surds are the same, which they are, because this is root 2 and this is root 2, if it was 2 root 2 plus 12 root 3, then you wouldn't be able to simplify it. But because these are both root 2, you can simplify this as 14 root 2. 2 root 2 plus 12 root 2 is 14 root 2. And that's how you simplify this. So you go through each of the terms, simplify them, and then you should be able to see what their sum is. Okay, so now let's do an example. I'll give you a couple seconds just to pause the video and just grab a pen and piece of paper and just try and do this one for practice. And after that, then I'll go through it and you can check that you got the right answer. So we'll keep this here so you can see how you would do it. So let's do example. Excuse my handwriting, I'm still getting used to this pad. So we have express the square root of 12 plus 2 times the square root of 27 in the form a times the square root of 3. Okay, so I'll give you a second now. You can pause the video and you can have a go at this one for yourself and see if we can get the right answer. Okay, so hopefully you've had a go at that now. Let's go through it. So let's just scroll down here. So exactly the same as the one we did before. We need to look at each of these terms, try and simplify them. You'll see the wording of this question. It doesn't just say simplify it. You do the exact same thing as before. All it tells you is that this is going to be what your answer at the end should look like. Okay, so you should end up with something times the square root of 3 should be your answer. So that gives you a little clue that if you're ending up with not this, or something that's not in this form, then you've probably made a mistake somewhere. So let's start with the first term, square root of 12. Well, this is equal to, 12 is equal to 4 times 3. And we can write this as the square root of 4 times the square root of 3, which is equal to, well, we know the square root of 4, that's equal to 2. So we can write that out as 2 times the square root of 3. And now this is good because we've got something times the square root of 3, so it's looking like we're doing something right. And then let's look at the next one. So we have 2 times the square root of 27. This is equal to 2 times, Well, what's 27? 27 is 9 times 3, right? So we can write it like this. So 2 times 9 times 3, sorry, the square root of 9 times 3 is equal to 2 times the square root of 9 times the square root of 3. And we know, well, the square root of 9, well, we know that 3 squared is equal to 9, so the square root of 9 is going to be 3. So we get 2 times 3 times the square root of 3, and our 2 times 3 is 6, so we get 6 root 3. So then last step, well, it says it wants the square root of 12 plus 2 times the square root of 27. So let's write that out. We've got the square root of 12 plus 2 times the square root of 27. And, well, the square root of 12 we know is equal to 2 times the square root of 3, as we've done up here. And similarly, 2 times the square root of 27, we know that is 6 times the square root of 3. So we can write it like this, and just as we did earlier, we know 2 plus root 3, 2 times root 3 plus 6 times root 3 is going to be equal to 8 times the square root of 3. And notice how this is in the same form as they've given us here. Oh, sorry. Well, the undo doesn't work for some reason. But this is 8 times the square root of 3. This is the form that we wanted, so it's likely that this is potentially right. You know, we haven't got 8 times the square root of 6 or something, because then we'd know that we've done something wrong. So yeah, good. This is the answer that you got. Hopefully you got that. So now let's move on to another question. So let's try something like this. So you've got 3 times 5 times the square root of 2. Sorry, this should be a plus. Okay, let's write this again. 3 plus 5 times the square root of 2 times 2 plus 3 times the square root of 2. Okay, so let's think how we would work this one out. Let's cover up my mistake. So if you've done algebra before, then you might recognise this kind of equation. Again, as it was for the last one, my video on algebra that I'll do, that may or may not be up when you're watching this, but I'll do a video on algebra and this will be helpful because the two are quite similar. But the way you would work something like this out is by using something called, or we call it FOIL. Okay. So if we look, we've got 3 plus 5 times the square root of 2 plus 2, sorry, times 2 plus the square, plus 3 times the square root of 2. So the way you have to work things out when you've got two things in brackets like this, so these brackets next to each other just means you're timesing them together, a little times there. So this FOIL stands for first, outer, inner, last. Okay, so basically this just means that when you're timesing these two things together, the way you do it is you have to first times the first, so if you look at the brackets, there are two things in each bracket, right? You've got, in this bracket you've got 3, you've got 5 root 2, in this bracket you've got 2 and you've got 3 root 2. So you have to times each thing in this bracket by each thing in this bracket, if that makes sense. So you'll have to do 3 times 2 and 3 times 3 root 2, and then you'll also have to do 5 root 2 times 2 and 5 root 2 times 3 root 2. So this FOIL just means the order in which you do that, right? So let's look at first. Okay, well the first things in our brackets, in this one, our first thing is 3, and in this, our first thing is 2. And you're timesing them together because that's what you're wanting to do to these brackets. So you've got 3 times 2. So this is the first thing you do. You've got 3 times 2, which we know is 6. Now we have outer. So that means the things on the outside. So that would be this 3 and this 3 root 2. Okay, so you've got 3. So you add on 3 times 3 root 2. Okay, now you've got inner, is the next one. So that's the things on the inside. So you've got 5 root 2 times 2. So add that on. 5 times the square root of 2 times 2. And then last you add on is the last ones. So that's this 5 root 2, and this is the 3 root 2, okay? So you have 5 root 2 times 3 root 2. Okay, so this first outer inner last just means you're timesing everything in here by everything in here. So you've timesed each and everything together, and you've added them all up. So this is what we get. So let's have a look at each part. Okay. So we've got here and we've got here. Right, this 6 is 6. To leave that how it is. 3 times 3 root 2. Well, you've got 3 times 3 times root 2. 3 times 3 we know is 9. So this gives you 9 root 2. 5 times root 2 times 2. Well, we know this 5 times 2 over here is 10. So you're going to have plus 10 root 2. Now this one, we want 5 root 2 times 3 root 2. So this is equal to 5 times root 2 times 3 times root 2. And because it's multiplication, we can swap things around. So let's, just to make it clearer, let's think of it as 5 times 3 times root 2 times root 2. Now this 5 times 3 we know is 15, right? And root 2 times root 2 is going to be 2. Because, well, let's think about it. Let's think, okay, well, the square root of 9 is equal to 3. And if we were going to do, okay, the square root of 9 times the square root of 9, square root of 9 is equal to 3 times 3, which is equal to 9. Okay, so if you're timesing some square root thing by itself, you're just going to get whatever's in here. Because you're doing the square root of something squared, so you're going to get whatever that something is. So the square root of 2 times the square root of 2 is equal to 2. And this is equal to 30. So we have this bit is 30. And then you can just add up each of the similar components. So you have 30 plus 6 gives you 36, and then 9 root 2 plus 10 root 2 is going to be 19 root 2. And that's your answer. Okay, so that one's a little bit tricky. If you know how to do FOIL from algebra, then that makes it easier. It's the exact same thing as if you had 3 plus 5x times 2 plus 3x. You would do it the exact same way, and then but it's just your x is root 2. If you haven't done algebra yet, then that's a little taster into what it will be. Okay, so we have this. Let's do another example because that was quite tricky. So let's look at 2 plus 3 root 3 times 6 minus the square root of 3. So this we have, okay, well we need to do using FOIL, first, outer, inner, last. So we got first, what's our first? Well, this is first in this bracket, and this is first in this bracket. So we get 2 times 6, which is 12, plus outer, so that's this and this, and take care of this minus symbol here. So we've got 2 times minus root 3, which is actually going to be minus 2 root 3. Okay. So now we have the inner, which is going to be this 3 root 3 and this 6, which is going to be plus 6 times 3 root 3. And then our outers, which is going to be plus 3 times square root of 3 times the minus square root of 3. So there's going to be 3 times root 3 times minus root 3. Okay, so this we get is 12. Let's change this to minus 2 root 3 plus 6 times 3 is 18, so this is going to be 18 root 3. And then we've got 3 times the square root of 3 times minus the square root of 3. So root 3 times root 3 is going to be 3. So it's going to be 3 times minus 3, which is minus 9. Okay, so this is going to give us, well, we've got 12 minus 9, which is 3, plus 16 times the square root of 3. And this should be our answer. Yeah. So let's do an example. Okay, so this is another one for you to do at home. So give the video a pause and have a go at this one once I've written it out. So we've got 3 minus the square root of 2. We'll actually do 2 examples here. And 3 plus the square root of 2. So that's this one. And then we'll also have 4 plus 2 root 2 times 6 minus 3 root 8. Okay, so have a go at these ones. The reason we're doing so many of these is because they'll become important for when we do rationalising the denominator in a bit. So give the video a pause and have a go at these ones now. Okay, so hopefully you've had a go. We'll now work through these. So let's start off with this one. Okay, so first outer and last using our FOIL. First ones, we get 3 times 3, which is 9. Outer, 3 times the square root of 2, which is just 3 root 2. This we get plus 3 times minus the square root of 2. Remember the minus here. So we get minus 3 times the square root of 2. And then our lasts, we get minus the square root of 2 times the square root of 2, which is going to be minus 2. Okay, because we've got root 2 times root 2 is 2. But remember, we've got that minus in there, so that's going to be minus 2. So we have 9 plus 3 times the square root of 2 minus 3 times the square root of 2 minus 2. Now this here, well, we can see if you've got something take away itself, that's always equal to 0, right? Like 4 minus 4 is equal to 0. 3x minus 3x is equal to 0. Anything take away itself is going to be 0, okay? So here we've got 3 root 3 minus 3 root 3. So this is just going to be 0. So we can just get rid of this. They cancel each other out. So we're just left with 9 minus 2, which is equal to 7. And that's our answer for this one. So note this bit, because this is going to be important later, the fact that we can get rid of these square roots, okay? And then let's have a look at this one. So we've got, again, first, outer, and last. First, we have 4 times 6, which is 24, plus outer, so we've got 4 times 3 root 8. Now, we've got this root 8 here, which we know from before we can simplify. So notice in all of these examples that we've done with this, these have been surds that we can't simplify. They're in their simplest forms. But here we've got the square root of 8, which we can simplify. So we can either simplify this now or we can simplify this later. And I would always suggest doing it now, just because it makes life easier for later, because otherwise if you don't do it now, then you often end up having to multiply big numbers together and it's going to take you more time than just doing it now. So let's have a look at this 3 root 8. Remember there's a minus, we'll have to remember that later, but let's look at this now. So this is 3 times the square root of 8, which equals 3 times the square root of 4 times the square root of 2, which is 3 times 2 times the square root of 2, which is 6 times the square root of 2. Okay, so this here is actually equal to 6 times the square root of 2. So let's actually, rather than doing this now, let's write this out again with this, just so that we remember it, okay? So we've got 4 plus 2 root 2 times 6 minus, remember it's minus here, 6 times the square root of 2. Okay, so it's always a good idea if you can simplify it to do that, because now we can see, look, we've got 2's here, so they'll cancel later when we times them together. Okay, so let's do this again with our FOIL. So first, 4 times 6 is going to be 24. Outer, this is going to be 4 times minus 6 root 2, which is going to be, well, 4 times 6 is 24. That's going to be minus 24 times the square root of 2. Let's do the inner now. So we're going to have 2 times the square root of 2 times 6, which we know is 2 times 6, which is 12 times the square root of 2, so 12 times the square root of 2. And then here we'll have 2 times the square root of 2 times minus 6 times the square root of 2. So 2 times minus 6 is 12. And then, so there's going to be the minus here. We've got 2 times 6, which is 12. And then root 2 times root 2, which is 2. So this is going to be minus 12 times 2, which this is just 24. So we've got 24 minus 24 root 2 plus 12 root 2 minus 24. Okay, so we've got 24 minus 24 here, which, as we know from this, is equal to 0. And then we've got minus 24 root 12 plus 12, minus 24 root 2 plus 12 root 2, which is going to be minus 12 root 2. Okay, so that's the answer for this one. So let's now move on to rationalising the denominator. Rationalising. Okay. So what does rationalising the denominator mean? Well, say you have a fraction, right? So we can be working with fractions now. So let's say you want, you have the fraction 2 over the square root of 2. So when we say rationalising the denominator, what we mean is making the denominator, which is this number at the bottom, so in this case it's the square root of 2, we want it to be a rational number, which means that it doesn't have a square root in it. Okay, so a number that has a square root where it can't be simplified is irrational, whereas just a number like this is rational. Okay, so we want to change this, the square root of 2, into a rational number, so we want to get rid of a square root, essentially. So how do we do that? Well, let's think. If you have a number, let's say number 13, and you times it by 1, you get 13, right? You're allowed to times numbers by 1 and they'll stay the same. So if we were to times this by 1, this would stay the same. 2 over the square root of 2. So we want to think, what number could we times this by to get it to be no square root? Well, if we were to do the square root of 2 times the square root of 2, we know that that's equal to 2, which is a rational number because there's no square root in that. So let's say we wanted to times this by the square root of 2. Well, if we're timesing the bottom by something, then we've also got to times the top by it, because we want this fraction to stay the same. So if we put root 2 over here as well, all we're doing here is timesing it by 1. We're just timesing it by a clever 1, so that the number, this still stays exactly the same, but we can manipulate this a bit. So let's do this. Well, how you times fractions, right? You times the top numbers together and you times the bottom numbers together. So let's do 2 times the square root of 2. Well, we can just write that as 2 times the square root of 2. And then this is divided by the square root of 2 times the square root of 2, which we know is 2. So now you can see that we have a fraction exactly the same as this one. They're equal to the same thing. It's just we've timesed it by 1. So they're still equal, it's in a different form. So, and now we can simplify this because we've got 2 on the bottom and 2 on the top. So we can divide this, and so this is just equal to the square root of 2, right? Okay, so let's do another example. Let's rationalise the denominator for 1 over 4 plus the square root of 3. Okay, so just as here, we want to times it by a clever choice of 1, right? So what do we want to times it by? Well, we want it to times it by something that will mean that this becomes the square root goes. So this is the little square root of 3 that we're looking at. So if we go back to the example above, this one that we did, you notice that we could times this by something, and we got this, which is a rational number because it doesn't have any square roots, okay? So you might notice about this that they're similar. This is 3 minus the square root of 2, and this is 3 plus the square root of 2. Now this is a little thing in maths, which again, if you've done algebra, you might know. It's called the difference of two squares. So say you've got, it's written as the formula of, you've got a plus b times a minus b. This is equal to a squared minus b squared. Okay, and this is why it works. So for this example up here, I can't have them both on screen, but your a is your 3 and your b is your square root of 2. So you have a plus b times a minus b, which gives us a squared, which is 9, minus b squared, which is square root of 2 squared, which is 2. So you have 9 minus 2, which is 7. So what we want to do here to get a rational number for the denominator is we want to use the difference of two squares. So we've got our 4 plus the square root of 3 here. So if we times it by 4 minus the square root of 3, and because we want this fraction to be 1, so that this doesn't change, we have to put that at the top as well. Then look at this, we're going to have 4 plus root 3, 4 minus root 3, and that's going to get rid of this root 3, and we're going to have a rational number here. Okay, so times the top together, we've got 1 times 4 minus root 3, which is just going to be 4 minus root 3. And then at the bottom, we've got 4 plus root 3 times 4 minus root 3. Well, we can use this formula. We've got a is 4, and b is the square root of 3. So this is going to be equal to 4 squared minus the square root of 3 squared. So 4 squared is 16, and then the square root of 3 squared is 3, and this is equal to 13. So this number down here is going to be 13, and that's it, that's your answer. You've rationalised the denominator, and now you've got a number here rather than a surd. So yeah, you just want to times it by, you just want to change this sign. So if this is a plus, then have the same numbers, but just change it to a minus. If this is a minus, then have this as a plus, okay? So let's do another example. So example, this is another one for you to do at home. Rationalize the denominator. Is that how you spell it? I think so. So we have 3 plus 2 root 2 over 7 minus 3 root 3. Yeah. So this is what you need to rationalise the denominator of. So I'll give you a second to do that, and pause the video and have a go at that one. Okay, so hopefully you've had a chance to do that. So let's have a look. We've got 3 plus 2 root 2 over 7 minus 3 root 3. So we want to times this by something, well, just as we did before, we're looking at this denominator, right, rather than this numerator. So we've got our minus sign here, and in order to use our difference of two squares, we need to times it by the same thing, but just with a plus sign. So this is going to be 7 plus 3 root 3, and because this needs to be equal to 1, 7 plus 3 root 3 is on top as well. So it doesn't really matter what you end up with on the top, as long as, because you're rationalising the denominator, it's what's on the bottom that counts. So, okay, let's do this. So we have 3 plus 2 root 2 times 7 plus 3 root 3. And then this is times 7 minus 3 root 3 plus, sorry, times 7 plus 3 root 3. Okay, so let's look at the denominator first. So we're still using our formula of a plus b times a minus b is equal to a squared minus b squared. So here our a is our 7 and our b is our 3 root 3. So we have 7 squared minus 3 root 3 squared. So 7 squared is 49. And 3 root 3, well, that's 3 times square root of 3 times 3 times the square root of 3. So you'll have 3 squared, which is 9, times the square root of 3 squared, which is equal to 3. So it's going to be 9 times 3, which is 27. So this is equal to 22. So this denominator here, you're going to have 22. Okay, so this is equal to 3 plus 2 root 2 times 7 plus 3 root 3 all over 22. And now let's look at this numerator. Well, we can do it the exact same way we were doing before and just use FOIL. You can also use FOIL to work this one out if you don't like doing it this way. Just this way is a bit faster. So, numerator, well, let's have a look. We have 3 times 7, so FOIL, first, outer, inner, last, first, 3 times 7, 21, plus outer, 3 times root 3, it's going to be 9 times the square root of 3. Inner, 2 times the square root of 2 times 7, it's going to be plus 14 times the square root of 2. And then we have 2 times the square root of 2 times 3 times the square root of 3. So that's going to be, let's just write that out. It's going to be 2 times, we can swap the order, so I'm just going to write it as 2 times 3 times the square root of 2 times the square root of 3. This is all over 22. This is going to be 21 plus 9 root 3 plus 14 root 2 plus, got 2 times 3 is 6, and then the square root of 2 times the square root of 3 is going to be the square root of 2 times 3, because as we know we can split them up and it stays the same if it's at times. So the square root of 2 times the square root of 3 is the square root of 2 times 3. Let's just write that out. Square root of 3 is equal to the square root of 2 times 3, and 2 times 3 is 6, so it's the square root of 6. So that's going to be 6 times the square root of 6, and that's over 22, and that's your answer. Okay, so it's a bit of a long one. I know the top looks all messy, but it doesn't really matter what the top is as long as your denominator is a rational number. And that is pretty much it for today. So I hope you guys found that useful. If you have any other questions, let me know in the comments, or if you want to do a one-on-one tutor session with me and I can go over things in more detail and explain things, then the link for that will be in the description below. But I hope that was useful to you. Thank you for watching. Goodbye.